Welcome to the School of Networking's session on basic networking. Today's our agenda is OSI model and TCPIP model. So OSI model was developed by ISO, International Organization of Standards, in 1984. The purpose was to have multi-vendor device compatibility, ease of development and troubleshooting. So these were the main intentions behind the OSI model. And this OSI model was modular in design and composed of 7 layers. So 7 layers were application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. So application layer was layer 7 and physical layer is layer 1. So the application, presentation and session layer are also referred as upper layer, and the transport layer, network layer, data link layer along with physical layer are referred as lower layer. So let's see what happens, how does the communication happen in OSI model. So let's say we have two nodes, one is a sender and two is a receiver. So each node has the 7 layers. So when the data is being sent, it will be sent from application layer going towards the physical layer, then on the wire, and on the other side from physical layer to the application layer. So this is how the communication would happen between the two nodes, and whatever is being initiated from the respective layer reaches to the same layer on the other side. So it is end-to-end communication. So at layer 4, if the header is added, it goes up to layer 4. Whatever header is added at layer 3 goes up to layer 3 on the other side. Same happens for data link layer. Whatever header and trailer are added at data link layer on node 1 goes up to data link layer of node 2 on the other side. So this is end-to-end communication between the two nodes. So when a data is being transmitted, so it starts with application layer. So application layer is the closest to the end user, and here we talk about protocols that are designed to work in a network. We don't talk about standalone applications here, we are talking about protocols. So protocols are a set of rules for certain task. So this is how, so examples of this are, for web we have HTTP, HTTPS, for email we have SMTP, for name to IP resolution or IP to name resolution we have DNS, domain name system. Then we have, for remote access we have telnet or SSH. For dynamically assigning the IP addresses we have DHCP, and then for remote access we have remote desktop protocol. So these are the few examples. There are many more. As protocol data unit at the application layer is referred as data. From application layer the data moves on to the presentation layer. So at presentation layer we representing of various kind of data formats like audio, video, photos, data. How do we represent them? So there are various formats of data like ASCII, text, then audio we have MP3, WAV, for video we have MP4, AVI, for photos we have JPEG, PNG, GIF. So there are various formats. These are the few. And along with that, while sending data, it can be compressed. So compression, and on the receiving side it will decompress. So along with that we can do encryption while sending and decryption while receiving. And the protocol data unit at this layer is again data. Then at layer 5 we have session layer. So at session layer we initiate, maintain and close the session. With that, we negotiate the modes of communication, how the communication is going to happen between two nodes. The protocol that works at this layer is SQL, remote procedure call, etc. And the protocol data unit that is present at session layer is data. We move on to the layer 4, which is transport layer. So at transport layer, if the data size is big, it is broken down into smaller segments. So segmentation happens at transport layer. Now at transport layer, we have two protocols, TCP and UDP. So TCP is connection oriented. So we need something called as sequencing and flow control. And error recovery is also done in case of TCP because it's a reliable communication. Whereas in case of UDP, we don't need to have a flow control or a sequencing. If that has to be there, it has to be built in the application itself. Now, besides this, error checking is present in both TCP as well as UDP, and we do multiplexing based on port numbers. We call it as service addressing based on port numbers in case of both TCP and UDP. And the protocol data unit that is there at transport layer is segment. So at segment, the data is, if it is bigger in size, then it is broken down into smaller part, and a layer 4 header which could be of TCP or UDP is added, and then it moves down to the network layer, that is layer 3. So at layer 3 we do logical addressing, that is assigning the address, IP address, so which consists of a hierarchy, that is a network part and the host part. In network layer we also do error checking. We check the integrity is in the checksum field, and the devices that are used at this layer consist of desktops, routers, multi-layer switches, on which we can assign the addresses, IP addresses. So the protocols that we come across are IPv4, IPv6, ICMP, and in olden times we had IPX and AppleTalk as well. Protocol data unit at network layer is called as packet. The segment that is received from the transport layer becomes the data part, and a layer 3 header is added, which can be either IPv4 or IPv6 header. So this becomes a packet. And it is handed over to the layer 2, which is nothing but data link layer. So at data link layer, we do physical addressing. That is, the MAC addresses are assigned in the header, and a FCS is added as a trailer, which is used for error checking. And the device that works at layer 2 are switch, bridge, or a NIC card, network interface card. And the protocols that we have at layer 2 as ARP, it could be Edge, 3G, 2G, 4G. So these are the protocols that are there at layer 2. PPP. When the layer 2 header and trailer are added, this is referred as frame. So the PDU at layer 2 is frame. Then before sending on the wire, MAC layer will check for the availability of the media. So before sending it to physical layer, so physical layer, that is layer 1, we have components like cables, connectors, and media. So if it is a copper, then we have electrons. If it is a fiber, we have a light, and if it is a wireless, we have a radio frequency. And the PDU at physical layer is bits. So onto the wire in form of bits, received at the other side on the physical layer, and then framing is done. On receiving the frame, it will check the integrity of the frame in the FCS. Then it will check whether the destination MAC address is the MAC address of the receiving node. If the condition is satisfied, then it will remove the layer 2 header and send it to the upper layer. However, if the integrity check fails, or if the destination MAC address is not the MAC address of the receiving node, then in both the cases it will drop the frame. Data part moves to the upper layer, that is the network layer. At network layer, it will check, is the destination IP the receiving node's IP address? If yes, then it will remove the layer 3 header and send the data to the upper layer. So at upper layer, it will again check whether the destination port is open or not. If it is open, then it will send the data upside. If it was segmented traffic, then in that case it will be reassembled here. Sequencing will be done and the data will be sent to the upper layer. And then it goes to the presentation layer and application layer. So this is how the end-to-end communication happens from sender to the receiver. Now in this process, while sending, we do encapsulation. So encapsulation is a process of adding control information as the data passes through each layer while sending the data. And on this decapsulation, so decapsulation is a process of checking and removing of control information as it passes through each layer while receiving the data. So while sending, encapsulation, and while receiving, decapsulation. So if we compare the OSI model and the TCPIP model, the application, presentation and session layer was combined as an application layer, transport layer was transport layer, the network layer was the internet layer, the data link in the physical layer was referred as link layer or network access layer. Now let's see how the communication happens in TCP/IP model. We have two nodes, sender and the receiver, and we have 4 layers. So application, transport, internet and network access. So data from the application layer is multiplexed to transport layer. At transport layer, as layer 4 header is added to the data, and if the data is bigger, it will be broken down into smaller segments. So at transport layer we have segment, a layer 4 header is added which could be TCP or UDP. Then this whole thing is moved to the internet layer. At internet layer we add a layer 3 header, so it is referred as packet. Then move to the network access layer. So at network access layer, header and trailer are added. This is referred as frame, and then it is transmitted over the wire. At the receiving side, again the frame is formed. It checks for the integrity in the trailer and checks for the destination MAC address is the MAC address of node 2. If yes, both the conditions pass, then it removes the layer 2 header and send it to the internet layer. So at internet layer, it checks the destination IP is the node 2's IP and checks the integrity of the header. If both passes, it will remove the layer 3 header and send the data to the transport layer. At transport layer, again it will check whether the destination port is open or not. If it is open, then it will remove the layer 4 header and send it to the application layer, and this is how the data is being received at the node 2. So this is how the TCP/IP communication will happen between the two nodes. Thank you very much and happy learning. Stay connected.